Maya, can you get the lights, please? All right, look up, please. So, give me a second. I'll wait. All right, a quick intro to slope. Now, some of you, if not most of you, already saw an introduction of this last year, okay? But once again, like everything, I try to introduce it in a different way to see if it makes a little bit more sense, or so you guys can start connecting some of the concepts that we need to connect. So, one way of introducing this is the following. Look up, please. Everybody knows that I meet up with the other teachers from the high school, right? We meet up at least every other month or so. Sometimes they come over here to my class, we all meet here, or sometimes I go over there. One of those times I was at the high school, there was a parent outside of the high school that they had just registered their son at the high school, and they're new to the district, and they needed to register their daughter at Frank Wright. And they asked me as I was walking out, excuse me, can you give me directions to Frank Wright? I'm all, oh, sure. I'm all, I actually teach there. Oh, hi, da-da-da-da, I'm Mr. Q, da-da-da-da, and so on and so forth. So I said, hold on, let me get my smartphone out, and then I showed him a map. Look at the map. Check this out. So I Googled it, and I said, we're here at the high school. And Frank Wright is over here. They're like, okay, I'm also getting your car and drive through these houses like this and get no, like I'm sure. So no, I did not give those directions. But the reason I'm making that obvious because from previous years, if not last year or the previous year, some of you thought slope as the line, and that is not true. The line is not the slope. The directions that I'm going to give the lady are the slopes. And I said, all right, lady, getting your... Okay, my bad. Guys, I'm very, just so that you know, I'm very good at numbers, but I'm very bad at names. So, for example, I'm going to give you an example. I think it was 2 years ago or something. They give us an activity. We're here, and then the guy's all, I'm going to flash some numbers on the screen, and they're like, there it is. It's 18 numbers. And he's all, they're right there. And right away, like I started looking at him, and then he's all, okay, you have 10 seconds to read them. Ready? Go. He blacks out the screen. They're like, write down the numbers that you can remember. So then we started writing down. Guess who got them all correct? Yeah, I'm very good at numbers, but once again, but if they were to say, oh, my name is John, what's the matter? Whoa, whatever, and then 10 seconds after he would say, can you write my name down? Guess what? I probably wouldn't know his name, right? You know what I'm saying? So, anyways, so I told the lady, okay, ma'am, get in your car, and this parking lot is open here. Does everybody see this part right here? Yeah. And you're going to drive through because the gate is open on this side. But look, let me show you on the map. Here's 1 street. You're going to go up 1, 2, 3, 4, 5, 6, 7. That's 7th Street up. And then you're going to make a right. You're going to turn 1, 2, 3, and 4 streets down. The directions that I just gave the lady, that is the slope. Because watch, what was the rise? How much did I go up? And how many to the right? And that forms the slope. So, once again, is the line the slope? No, because the lady will crash through those houses like that. The directions to get from point to point on the line is the slope. Everybody understand that? All right, so that's a good way of intro the lesson for today. And our objective for today is I can define and find the slope of the line. Let's read together. 1, 2, 3. I can define and find the slope of the line. Write that down, please. Lights. All right, here we go. So in your Freire model, what is our concept for today? Slope. So that goes in the center. Write that in the center. Slope. Definition. Slope. What is it? It's the change in y value, which is a rise, per unit of change in value x, which is a run. It's always the same, and it's known as rise over run, or the slope of the line. Rise over run, we can write it as a fraction. Here's a fraction, rise over run. Now, as you're copying these definitions, check this out. Whenever you get to the phrase always the same, you can write next to that or in parentheses or equal to. Always the same, we're going to use the word constant. 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 It's always the same. It's constant. Copy that, and I'll show you some examples. All right, examples. Write these down, please. This is an example of a positive slope, and once again, we know that the line is not the slope. Is that correct? Yes. This is an example of a negative slope. We know the line is not the slope. This is an example of undefined slope, and this is an example of zero slope. So as you're copying that, okay, we established already when we started graphing that whenever we graph, we read our graph from left to right. So look up, please. So look at this green line. What would be the first point that I would touch on that line if I go from left to right? Would it be down here or up here? Down. So this would be our first point. Look at this red line. Which would be our first point, the top or the bottom? Top, because we're going from left to right. How about this one? Undecided, because we don't know whether it's this one or this one. Everybody with me? And here, the first point would be here, but I'll talk about the zero slope on that one a little bit. So here, let me elaborate on why these are positive and why these are negative. An easy way of putting this is as follows. When you guys leave here the valley and you go on to other things, and I'm not going to say better things, I'm going to say other things because I know you guys are going to do better, so that's a given. So let's say you leave the valley, and once you leave the valley, especially you're going to be in cities that they have these apparatuses. Look up, please, that is a person. Watch. When you get to these major cities that you're going to be living in while you're going to school or getting your career underway, there's these apparatuses that when you step up like this to that apparatus, all of a sudden it takes you up automatically like that. They're known as escalators. And then you can get on the other one like this, and it takes you down like this. So watch. So if this one goes up, that's why it's a positive slope. If this one goes down, it's a negative slope. So watch. Look at this one. This one is undefined because we don't know where to start. If it's up here or down here, that's why this slope is undefined. Now, some students tell me, Mr. Q, well, there are escalators that are flat like that. That is incorrect. They're not called escalators. They're called, I don't know. I got it. They're called terminators. Bam. No, actually they have them in Las Vegas and some of the strips in the airports also. However, for the purpose of today, I'm only looking at escalators. So is this an escalator? No. So if I step on, is it going to take me anywhere? If I step on this that is not an escalator, is it going to take me anywhere? That's why it's zero slope. So, with that said, let me show you examples of, non-examples of slope. Look at those. Graph those on your non-example, and as you're writing them down, start thinking these are not examples of slope or representation of slope because Talk it over with your neighbor. Why are those not a representation of slope? Okay. Charlotte, why are these not a representation of slope? Bam! You ever hear that? Because they are not constant. This one breaks the continuation here. It's constant up to right there, but then it breaks, and then again, and same here. Goes down, goes up, so it's not constant. So, with that obvious response, what would be our first obvious hashtag? Constant. That is correct. Who can give me another one, Brian? Bam. Rise over run. One more, Francesca. Escalators. That's fine. And one more, last one. Who's got one more? One more.
Oh, I know.
Okay, go ahead.
Okay. Hashtag slope.
Whoa! What? That's fine. Write those down, please. And then after that, write the following steps. You only need 3 steps for today. Here we go. 3 steps. Step 1, identify 2 points on the line or a table, then write the coordinates. Step 2, compute the vertical change over the horizontal change, also known as what? Slope. And at the end, you're going to simplify. Copy that, please. Okay, here we go. Get the graph paper in front of you, please. Get the big coordinate plane.
I don't have a I don't.
Here we go. There's some in the back, or look for some at another desk. Okay, here we go. On the big graph paper, on the top right, I want you to write example Q. Write the instructions. Identify the slope of the line that passes through parentheses -4, -1, and 4, 3. Bless you. Bless you. Okay? All right, here goes the process. First things first, let's plot those 2 points. -4, -1, -4, -1. The other one is 4, 3, 4, 3. Once you have your 2 points, grab your ruler and make sure you make a straight line that goes through the entire coordinate plane, please. Okay? All the way across, make sure it's a nice and straight line. I know it's not going to be as nice as mine, but just, try your best. I am. I'm telling you that it's okay if you make a mistake. Okay. Here we go. Look up, please. So, out of those 2 points, which would be my point number 1? -4, -1, because we're reading from left to right, and that comes up first. So, if we were to give directions, here's the high school, here's Frank Wright. Let's count how many steps up from here. 1, 2, 3, 4. So our rise is 4. Then we make a right, and how many to the right? 1, 2, 3, 4, 5, 6, 7, 8. And then the symbol for slope, we're always going to use the letter M. M equals, or slope equals, rise over run. So what was the rise? 4. What was the run? 8. And last step, it said to simplify. This becomes what? 1/2. Yes. Because they use the letter S for something else. And they, so, yeah. Slope. All right, here we go.
There's no M in slope.
I know. Guys, focus, focus. So, we found our slope. And those were 2 points. But according to the definition, what was the key word that we're working on today? Aside from slope, what was the other key word? Constant. It's constant. So what does that mean? It means that it doesn't matter what 2 points on the line we choose, the slope will always be the same. So watch. I'm going to choose 2 more points. I'm going to go to the extremes. I'm going to choose 10, -4. Plot your point on yours. And I'm going to choose 10, 6. 10, 6. Yeah, I said -10, -4. Oh, sorry. -10, -4. And 10, 6. All right? So let's find out the rise from here to here. How many steps? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I make a right turn. How many to the right? 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Therefore, my slope for those 2 points on the extremes is 10/20, and simplified is 1/2. And what is the constant rate? 1/2. Yeah. Sure.
On the first dot, why do you start one above it? Because, like, if you start calculating up, you start, like, one above where the dot is, where the point is.
If I ask you to stand and I ask you to take a step, where are you going to start? Are you going to count where you're standing?
No. But exactly, that's my point. Exactly. Then why don't you count the last one, the last dot?
Because you're stepping from here to here. You're trying to reach that point.
One step forward, you count it just like... It's like taking...
Damn. Constant rate of change, yes. Guys. All right. Now, Lily said, Mr. Q, so is 1/2 the constant? It's the constant rate of change. So what is the rate of change? 1/2. That means for the rise of 1, 2 steps to the right, you should end up at another point. Let's see if that's true. Let me zoom in. Look up, please. I'm going to start here at -4, -1. Are we there? So watch. What is the rise over run? 1 up and 2. Do I end up on the line? Yes. Let me do that again. 1 up, 2. Yes. 1 up, 2. Yes. Is it working? You're like, what? Yeah, it's a pattern. So now check this out. Earlier I had a student, look up please. Earlier I had a student and they were like, usually there's some of you that try to, I don't want to say challenge what I'm giving you, but you try to approach it in a different way. So they said, Mr. Q, I see what you're saying, But how come you're only choosing these corner points? Why can't I choose this point? That's not at the corner. And I said, all right, let's use that point. Look up, please. So I'm going to use this point and this point. Are we there? So watch. This point is -4, -1. Do you agree with that?
Yes.
This point is 1 and 1.5. Are we there so far?
Yes.
So we're going to get from here to here. So I said, okay, how many steps do I take up? 1, 2, and a half. So this is 2.5. I make a right turn and I go 1, 2, 3, 4, 5. So my slope is, what is the rise? 2.5 over 5, which is what? Why? Let me ask you this, and I want you to think about it first. Don't say it out loud. Let me ask you this. Why does it work with any 2 points? Talk it over with your neighbor, please. Why does it work with any 2 points? I know, right?
We have to choose a word. Football is the type. So we might just be like,
Bam. All right. Jillian. Oh, here you go. What did your neighbor say? Because it's a constant rate of change. So it doesn't matter what points you choose, the answer will always be the same. Everybody got it? All right, so turn your paper over, your graph paper on the medium graph paper. I want you to plot these 2 points. -2, 6, and 2, 3. Label that example super Q. Yeah, the one on the left. So these are the 2 points. Plot them. Graph your line. Stop the helicopter thing with the rulers. Thank you. Plot your 2 points. Graph your line. Find me the slope, please. Keep it to yourself. Don't say it out loud. Let people think. And this one has a little curveball. See if you catch it. Go. Talk it over with your neighbor. See what they got. See if they have the same thing as you. Alright, let's see. I'm going to plot my point, -2, 6, right there, 2, 3, right there, and then my line has to go through those 2 points, right there. Does yours look like that?
Yeah.
So,
No, it has to go all the way.
oh, all the way, my bad.
Wait, why does it have to go all the way?
No, because whenever you want to check for slope and you want to cover all the points, make sure it covers all the points in the coordinate plane. All right, so check this out. That's our line. So before I call on people that made a mistake, let me give you another opportunity to change your answer. Look up. This line represents what kind of slope?
Positive.
Okay. Don't say it out loud. Look at this line.
Oh, okay.
So, with that said, Noel, what did you get for your slope? Okay? 3/4. What didn't she change? Philip? A negative, because this represents a negative slope. So now, so that you remember next time, look up. Point number 1 would be this one right now, yes? Point number 2 over here. So to get from here to here, I go 1, 2, 3 points, or 3 steps, which way? Down. That's why it's a -3. Yeah. Yeah. At the end. And then how many to the right? 1, 2, 3, 4. That's why we write negative 3 over 4. Matthew, go.
What happens if you went to the right first?
Yeah, that's what I did.
To the right first, that's fine, as long as you understand that this is a run. And who notices, guys, who notices if you go to the right first, 1, 2, 3, 4, it's still run and it's still a positive number? Who notices that? Which is the only one that changes? The right. It's either positive going up or negative going down. We got that?
Yeah.
Okay, yeah.
What, if you're going sideways, it has to be the
Run.
right?
Yeah.
Oh.
And so that you remember, look up, rise over run, it's the y over the x, right? Change in y over x. So look, see if you remember with this. The y is rising like that. Who notices? They're going like that. And look at the x. Isn't the x running? That's cool, huh? They're going like this. So watch it be like I zoom in and the X is dabbing. Oh, never mind. No? Okay. Be nice. All right, get your Cornell note. Flip your Cornell note over, and I want you to sketch me an X and Y axis.
Yeah, walk in the big camp.
What's that? No, I understand, but I don't want it numbered. I want to see how well your noodle's going right now and see if you understand the main concept. Yes. Oh. Okay, it fits underneath. That's fine. All right, so here's your coordinate plane. Label your x-axis and your y-axis. Is my y-axis straight? Yeah, right? There it is. All right. Also, I want you to place a point right there and a point up there. All right. So here it goes. We're going to go a little bit fast, so pay attention. Write your utensils down. You'll finish. You'll copy at the end. Here it goes. Look up. So notice here I did not give you values anymore for the x-axis. But step number 1, which would be our first point? The bottom one. So I'm going to label this one 1 and this one 2. Okay? Now, for this point, we know this point has an x value and a y value. Is that correct? This point also has an x value and a y value. So if I ask you to write the coordinates for the first point, you're going to write x, y. If I ask you to write the coordinates for the second point, you're going to write x, y. But that's confusing, right? So here goes some thinking on your part. How can I distinguish these from these? Think about it. Don't say it out. My goodness. Don't say it out loud. Let people think. How can we distinguish these two from these two so that we know that which one is point 1 and which one is point 2? Talk it over your neighbor. What can we do? What can we do? All right, let's see. I heard somebody say write a 1 and a 2. So watch. This is what I'm going to do. For these two, in order to know that it's for point 1, I'm going to write x sub 1 and y sub 1. Therefore, these coordinates are x sub 1, y sub 1. Does that make sense? Sub 1. Therefore, what would be the coordinates for point 2? X sub 2, y sub 2. Are we there so far? And that's why they use that notation to differentiate from point to point. Does that make sense? Yeah, the words are a little bit, funky, but we understand the main concept, right? So, with that said, look up, please. here goes some more thinking to do. Look up. Now that we got established that, and this is 2 and this is 2. Now I'm going to give it some values. Look up. Let's say this is 2 and this is 6, this is 1 and this is 8. So let me ask you this. Look up. If I wanted to get from here to here, what is the rise? 7, okay? And if I wanted to get from here to here, then it's 4. Are we there so far? So my slope, what you are saying, is 7 over 4. Do you agree with that? Okay, so watch. Here it goes. Look up, please. Stop writing, please. Look. Talk it over your neighbor, see what happened there.
That's the point.
Okay. Tell me what to write right here, Lily, to get this. 8 minus 1. And what do I write here, Lily?
6 minus 2.
Hands if you agree with that.
Yes, I
Okay.
like
Okay. So now here goes the mind-blowing part. Look up, please. We're almost done. Don't worry about the bell. It's gonna ring in a little bit. I want you to focus. Here it goes. M equals. Watch. Look up. What if I didn't have these values? So look. What would 8 be? No, what would 8 be? Minus over minus, and that's the formula for slope. Bam! So our home plate for tonight is on pages 176 through 178 only. Isn't this cool? You know what I'm saying? How we're discovering stuff?
I love the only part.
The only.
Today, I am like, I know.
Bye, guys. Have a good one. Enjoy your home play. See you guys tamales. Bye.